continue. All right, so this should now be recording. And I want to first draw a template of what I'm going to show you and then show you how to do it in prose. So for the Clawbot 2.0 project, we need to combine a lot of the skills and programming techniques and setups that we've already created for our Clawbot. So I want to give a little quick guide on how I would put together that Clawbot 2.0 project. Now, there's going to be two ways to do it, and I'll show you both ways. This is based on feedback that I've already got from students. So like it says here, you're going to need to first complete projects 3 through 6, so you have background familiarity with each of these pieces of the programming. Then you need to set up a new prose project called Clawbot 2.0. Then the first thing I would say you should do in your new prose project is to set up the functions that you're going to use in your project. So you're going to set up functions to control motors. You're going to set up functions to do special tasks like homing joints and holding joints at specific positions. And you're going to need to set up the sensors that you're going to be using as part of your project. Once you've done all of this setup, okay, then let me tab backwards here. Then you're going to need to set up your op control, OP control file. And you're going to need a button on, you're going to need to have a button on the joystick that calls every single one of your functions. In other words, each of the functions that you've made, you're going to need to be able to execute them using buttons on your joystick. So set up OP control file, and we call this mapping. Map a button, or buttons, I should say, on joystick to each function. Okay. Before proceeding, what I'm going to do is test that all functions work. In other words, I'm going to just use a print statement in each of my functions. It's always good to put a print statement in each function, so you know that that function got called. So I'm just going to set up a print statement in each function to make sure that every single function works. In other words, when I press the button, the function runs. So that's going to be my second step. This is kind of like a little checklist, and I can share the checklist with you as well. Okay. Once I've tested all the functions and I've created an op control program that will call all the functions, then I think the last step would be, or the last major step would be to fill in each function with the code to do the task. Okay. Now, in most cases, this step, you've already completed this. You've already built this code in other projects. So for this step, it's mostly going to be some copy and pasting of code that you've already created. And in some cases, like you've maybe created a code to home your shoulder. Now you're going to copy that. You're going to paste it into home your shoulder, and then you're going to paste it into home elbow too, and just make some small changes. Like, for example, instead of moving the shoulder joint, you're going to move the elbow joint. So you'll change which joint you call. And instead of using the shoulder limit switch, you use the elbow limit switch and things like that. Okay, so you're going to fill in each function with the code to do that task. And this step's going to be include, copy, paste code from previous projects. And this step's going to include modifying code for specific task. Okay, so in most cases, it's going to be copying and pasting it and then making changes like which motor you're running and things like that. Okay, for that specific task, let's say. All right, just making some spell checks. All right, so I'm going to try and go through these steps. I'm going to tell you 2 ways that you can go through these steps, and I'm going to do that in prose, and hopefully it only takes about 10 minutes for each way. All right, remember, I'm recording this, so you can come back and watch this again and see each of the steps, what I did in prose. All right, just checking that I was recording. So step 1, create a new prose project for Clawbot 2.0. Sorry, I pressing the wrong button. It looks like I'm going to need to restart prose. Okay, while I'm restarting prose, I can let you know that the two ways I'm going to organize this is one way I'm going to put each function in its own file, which is the way that Prost user guides recommend that you build your project. This can be more convenient because you can create small pieces of code in their own file and therefore navigate through your program more quickly. The other way I'm going to show you is to put all of your functions in a single folder. And both of these techniques would work for your project. There's no reason you can't do one or the other. It's just a question of what you're more comfortable with and what makes more sense to you. All right. So I'm now getting Prost open here. And I'm going to just close these welcome screens and stuff. All right. So again, we make a new Prost project using the Create New Project button. So under Prost, I'm going to go New Project. Okay. It is very important that you don't just hit Save here, that you actually choose a place that makes sense to create and save your project, because you're going to need to find that folder later when you're ready to download the project to your robot. So don't just save it in your username and My Prost Projects. That's going to be someplace you're never going to be able to find again. Choose a folder that you're familiar with using. So you can click the little folder icon here. And you can choose somewhere like your desktop or your documents folder or some other place that you're used to organizing your project. So in my documents folder, I have I'm going to create the project right here. That's where you can see my other Prost projects. So I'm going to create it inside documents. Okay. And I'm going to make sure it's a Cortex project. And this one's going to be called in documents. Then the folder name is going to be Clawbot. Clawbot 2. I don't think I can use decimal places, so I will just try it like that. Okay. This is now going to create my Prost project. So my first step, once I've created my Prost project, is to create all the functions that I'm going to need in my project. Okay. So I would recommend that you do a little bit of cleanup here. So we're going to remove the comments from op control, so we don't have extra code. We're going to move the comments from init.c. We're going to remove the comments. We're not really going to be using auto, so I'm not going to clean that one up. Okay. Then the next thing I'm going to do is I'm going to go into main.h. I know I'm going to need to add code in main.h. I'm going to clean up these comments. Okay. And you can see that main.h is going to run autonomous, initializer, and op control, depending on which one gets called. And when you add code to main.h, when we're going to declare our encoders and such, you need to make sure you add that code after you do have the include API here. Otherwise, your functions won't work. So I'm going to create some space here. And this goes here. Place main.h code here. So this is where I'm going to put anything that I need to add to main.h. It's going to be right here, right? And API.h you generally shouldn't need to mess with at all in any way. All right, so all I've done so far is clean up the default files that are generated. And now I'm going to start doing the first step, which is to set up the Prost project, Clawbot 2.0, and then to set up the motor control functions, okay? By motor control functions, I mean that in the assignment instructions, it says you need to be able to control, that wasn't Google Classroom. In the assignment instructions for Clawbot 2.0, it says you need to be able to control the drive motors, the shoulder motor, the elbow motor, the wrist motor, and the claw motor, okay? So I'm gonna show you first version 1 on how to set that up. So version 1, we're going to go, I'm going to right click on the include folder and I'm going to go new file. Okay. And I'm going to name a file for each one of the joints. So this one is going to be my drive, which we call also the chassis. So chassis.h. Okay. Then I'm going to right click the include folder again. I'm going to create a new one. So new file. And this new file is going to be called shoulder.h. Okay. These are just errors that pop up. Nobody's really sure why. Well, I'm sure somebody's sure why, but we don't really care about them right now. So include now includes chassis and shoulder. And if I keep going through the list, I need to also control the elbow. So I'm going to create a new elbow.h. And I'm going to create a new, these are all files, a new wrist.h. Close these errors that pop up. And finally, I need to create a new claw.h. Okay. So this is method one, where every single function is going to be in its own .h file. The nice thing about this is that when I need to find my claw function, I just click on the claw.h file and I'll find my claw function there. All right, I'm going to close these windows because we won't need all of these yet. Okay, so in addition, if we look back at the instructions here that I was working through, we need to set up special task functions. So the special task functions include things like homing the shoulder and things like holding the shoulder and elbow joints in position. So I'm also going to create new files, include home shoulder.h, home my shoulder. I'm going to include a new file, home elbow.h, which is going to home my elbow joint. And then project 6 is to create closed loop control to hold the elbow joint and the shoulder joint, the two joints within coders, at specific positions. So that's another functionality I need to add to my project. So we could call these files hold elbow or lock elbow or closed loop elbow or something in between. Okay, so I'm going to call this function hold elbow.h, and I'm going to make one more. Home shoulder, sorry, hold shoulder. Okay, so within each of these within each of these files, there's currently no code at all. Okay, and again, this is strictly an organizational technique. You can organize a new folder, a new file, a .h file, and we're going to put the function for each of these tasks within its .h file. Okay, so let's look at how we're going to start adding those functions to these files, and then we'll switch gears and look at one other way that you can add all your functions. Okay, so we've so far set up the control functions, the motor control functions. We set up the special task functions, or we're most of the way there, and then we'll set up the sensors that we're going to use. Okay, so right now there's no functions in each of these folders. So what we want to do is add a function with the same name as the file, because that's the name of the function that we're going to use. So the chassis, and we're going to make that function called set chassis or set claw or set elbow or home shoulder, etc. Okay, so the default template for adding to a function here can be found again if you want to reference it. If you go to this Google Drive folder, the Clawbot example code, the Clawbot 1.0 example code. Oh, that was on the wrong project. Sorry, that's project. Huh, why does that take me to the wrong place? Let me go here. And where did I first? I think I first published it here. Okay, so if you look here at sort of a standard one of the include files, let's just take elbow.h, for example. They all follow the same format. So you need the two sort of declaration lines at the beginning. Then it's good to include the API. Make sure you can use any of the functions from the API. Include main, and then you just include the function. So I'm just going to copy this. And so let's go through each of these. So for chassis.h, again, I'm just going to create an empty function in each of these. So I will come back and I'll put the contents of the function in here in just a second. So right now it's an empty function. And this one, we want to call it chassis set, because this is in my chassis.h file. Okay. And then instead of elbow, we want to call this chassis. That's the same name. Oh, it should be all caps. The same name as the .h file. Okay. And include main should be in all of them. Okay. And what we're going to put in each of these, like I said, is we're first going to put just a print statement so that we can make sure that all our functions work. Okay. So the generic print statement here, again, I can show you where to find it in the example. If we go to src and the op control to print something onto the serial or the terminal, we can just use the command printf and then the statement that we want to print. So we're going to put just a print command here, and we're not going to print the loop count or anything. We're just going to print the name of the function. So chassis set function called, so that when we press the button, we're going to see this. So I'm going to take this little example template, and I'm going to place this in all of my different functions, just changing the name of each. So inside claw, instead of chassis, we're going to change this to claw. Change this to claw. We're going to change this from chassis set to claw set. And then I'm going to change this from chassis set function called to claw set function call. Okay. And we'll repeat this little activity. Need to do the same thing for the elbow. Okay, and then this is going to be elbow set. This one's going to be elbow. Okay, same thing for home shoulder as well. Again, we'll put the same text name as the name of the file. So this is hold shoulder. Hold, all caps, sorry. Hold shoulder. Hold shoulder, and then we're going to call this hold shoulder is going to be the name of the function, and then the hold shoulder function is called, and we can do the same thing here on hold. Sorry, I put that all in hold elbow, so let me put that in home. That should be hold shoulder, and this should be hold elbow. And so we've done home shoulder, hold shoulder, and hold elbow. Now we can do home elbow and home shoulder. So it can be a similar thing. Okay. For now, I'm just going to paste that, and then I'll go back. And so this is home elbow. So home elbow. And then one capital elbow, and take out this integer here. Okay, this one's going to be the home shoulder. And change it up here. Okay. And then finally, just the shoulder set function. So this is just shoulder.h. And the shoulder set functions. Set. And here it makes sense. Oh, one more thing. Shoulder set. Okay, so now with the exclusion, darn it, I have to do wrist, but we'll ignore wrist for just a second. With the exclusion of the main and the API, we have a function. Okay, in this case, all the joint control functions are using the integer speed is getting passed to them. So then we have a hold shoulder. This one should have an integer angle, because the hold shoulder will hold it in an angle. Sorry, home shoulder has an integer of home position. Okay, home elbow has an integer home position. This is the integer we're passing to the function. Hold shoulder has the integer angle, because it's going to hold the shoulder at an angle. Hold elbow has the integer angle. Okay, and then the elbow has the integer speed, because you're going to set the elbow to a speed. You're going to set the claw to the speed. You're going to set the chassis to a speed as well. The chassis has to have 2 speeds. So I think it would be int right and int left. There needs to be a, okay. So this is what I mean by completing this step here, setting up all the motor control functions and setting up the special task functions. And the last thing we need to do is set up any of the sensors that we're going to use. Okay. Now, it's not necessary to put all your functions in a separate .h file and end up with a total of 7 or 8 .h files. Like I said, to me, this is convenient because I can quickly find the claw code, I can quickly find the chassis code, and so on and so forth. But if you prefer to have a simpler file tree, in other words, fewer folders here in the file, we can set up, I'm going to set up another project that's very, very similar, but is maybe more simple to your liking. So I'm going to create a second home pro, sorry, that's compiling it. Hopefully it compiled successfully. Okay, so I'm going to press pros, new project, and we're going to call this one Clawbot 2.0.1. Okay, so this is a very similar project, but just with a slightly different format than the previous one. And I'm just going to drag and drop things from the first project I made into the second project to show you. It is not necessary to make 2 projects. I'm just doing this as a little example. Okay, so here in the include folder, we just have these 2 .h files. So another way that you could organize your project is to include only a single additional .h file. This one I'm going to call new file, and I'm going to call this include, and then we're just going to call this functions. Functions.h. Okay, so in functions.h, let me close these little errors that are going to pop up. I'm going to store all my functions in a single file. Okay, so let's look quickly at what this would look like. Now, I still will need to start these 3 lines at the beginning of my .h file, except with the name change. So instead of chassis, this is going to be called functions. Okay, and then I need the other thing that has to be in any .h file is this end if statement. So let's put that one in as well. Okay, so again, this is just the default template for a .h file. Now, you can store as much stuff as you like to in your .h file. What could you store? Well, you could, for example, store all the functions to control your robot. So I could remember when the void is what declares a new function. So I could take this function, which is my chassis set function, and I could place it within my functions folder on my other project. Okay, then I could similarly go through and get the claw function, which is just this, and place it into my functions folder. I could go get my elbow function, which is just the part from the void and the open and close parentheses, and I could place my void function in here. I could go get my hold function. I'm going to copy that, and I'm going to paste that function into here. And you probably get the idea here. We're going to end up with a single file with all of the functions that I need for my project. A void chassis set, a void claw set, a void elbow set. Let's make some space here, and let's make sure we go get the other functions. So I'm going to open up this. We did the elbow. We need to still do the shoulder. So again, just the shoulder set function. I'm going to put this into my functions folder. Okay. Elbow set, so we have chassis, claw, elbow, shoulder, wrist function is the one we need. That's the function we didn't yet create, so let's create one right now. We'll base it off the shoulder function. And we're going to have wrist. It's just throwing an error because I defined things twice. So wrist set, and then print here set function called. Okay, then we have the home shoulder. We can, of course, make a home elbow function. Okay, we can make a hold elbow. I'm not sure why it's doing this auto indentation. It's kind of annoying. I just have to untab this a lot. So hold elbow, we're gonna, sorry, that was hold shoulder and hold elbow. So then we're gonna have home elbow, and also home shoulder. Again, this is just some backspacing necessary to make this look a little bit normal. And then, so this one, and of course it throws an error because I changed this to shoulder, and change this to home, and this to home, and this to elbow. Okay, so in this single file, this single .h file, I have all my functions: chassis set, claw set, elbow set, shoulder set, wrist set, hold shoulder, hold elbow, home shoulder, all in one file called functions. And there's no reason you can't do this. Okay, all of these, once I do the, once in my op control, I put the include functions file in my op control code set, then there's no reason I can't access all the functions and save them in one place. Okay, so those are the main 2 differences. Project 2.0.1 has only one .h file that includes all my functions. All my functions are going to live here with their associated code. Clawbot 2.0, the first one, has a different file for each of the functions. All that lives in any of these given files is a single function inside each of these. Okay, just a single function. The rest of this is just file management, basically. The stuff at the beginning, the stuff at the end. The only thing that's really active in here is this function, and I will call that from my op control. Okay, I want to pause here. Does anybody have a question about these two different ways of storing your functions within your projects, like I showed you in Clawbot 2.0 or in Clawbot 2.1? Okay. Again, you can type questions as we go in the chat, but I don't hear any questions from you. So you should decide which you prefer, the Clawbot 2.0-1 with all the functions in one folder, or the Clawbot 2.0 with a different folder in each function. From here on forward, there is no difference really in the rest of the programming. It's just a question of whether you want to be doing all your typing in one place or if you want to be doing your typing in a different file for each part of the project. So let's move on now to the next step. Set up op control file and map buttons on joystick to each of the functions. Test those functions. Oh, we have to do the setup sensors. So let's do setup sensors, then we're going to set up the op control file, and then we're going to do the next part. And like I said, there's not very much difference in these next steps between the two. I'll do it in Clawbot 2.0, but we can just copy and paste our code over to the other one. So let's talk about sensors. Sensor setup has to happen in main.h, okay? Sensor setup also needs to happen in your init.c folder. So the sensors that we need to set up, let's put them in here. Tab. Okay, we need to set up 2 encoders. So we need to set up a shoulder encoder, an elbow encoder, and I can call those shoulder encoder and elbow encoder, or I can call them encoder 1 and encoder 2, that doesn't really matter. And then so far we have a shoulder limit switch, and we can call this lower limit switch or upper limit switch or shoulder limit switch, they're just names, and the elbow limit switch. Okay, so shoulder encoder, elbow encoder, shoulder limit switch, elbow limit switch. Those are the sensors that we're going to be needing for this project. An encoder and a limit switch for each one. Okay, so let's start about what you need to do in main. In main, you need to declare encoders. When we get to the distance sensor, you also have to declare the distance sensor, but that's basically just to run a function to set up the encoder. So the function name is capital encoder, so encoder is the name of the function. This is a pre-built function in Prost, okay? And the function encoder then should be followed by the name that you want to set your encoder to be. So we could call this encoder 1, or we could call this encoder 2, or we can call this encoder shoulder encoder, or elbow encoder, or anything else that we like, okay? These are just names that we need to place after this command encoder. So I'm going to call my encoders encoder and elbow encoder. Anytime we want to read or access the value of these encoders, we just use these names, okay? So the first step is to set up the names of your encoders. Now, if you want to name your limit switches, you're going to do that here as well. You're going to use hashtag define. Okay, and then you're going to put the name of your limit switch. So this could be lower limit, okay? Or you could call your limit switch shoulder limit switch. Okay, or you could call it limit 1 and limit 2. It's up to you. So for this example, I'll call one shoulder limit and one define elbow limit. All right. Now, after the name, the last thing we need to put is the port number. So if you look at the Clawbot instructions and you go to the very last page of the Super Clawbot instructions, I think it's going to make the most sense for us to follow that guide as where these different things should be plugged in. So if you go in Google Classroom to the Build the Super Clawbot assignment, you can find the Build the Super Clawbot build instructions here. And this is going to take just a minute to load. But I think to avoid confusion in my presentation, I'm going to follow the port assignments shown here in this document. And I think you should, unless there's some reason you can't, you should plug in your encoders, your limit switches, your other sensors in the ports assigned here in the document. You should follow that. And that's going to be the easiest way for you to stay on the same page. So if you go to the very, very end of this document, we're going to go all the way down to the last page. It'll take a little second to load. It's going to give a little chart with where each thing is plugged in. Okay, so here under the digital section, we have ultrasonic sensors in port 1. Ultrasonic is in port 2. Then upper limit switch is going to be in port 3, and lower limit switch is in port 4. Upper limit switch is going to be on the elbow, and lower limit switch is going to be on the shoulder. So I'm going to set my shoulder limit switch to 4 and my elbow limit switch to 3. So we're going to go back to pros here. So this one, shoulder limit switch should be on 4 and elbow limit switch should be on digital 3. And we need to just end this with a semicolon, I believe. Elbow limit, what does this say? Valid processing, I have some kind of a...
You spelled it wrong.
I just spelled define wrong? Oh, yes, I did. There we go. Okay, so this is the first step of setting up sensors. Again, you're naming your sensors. Here, I named my shoulder encoder. I named my elbow encoder. Here, I named my limit switch, and I set what port it's on, and I named my other limit switch and set my port it's on. The second part of setting up sensors is in the init folder. We need to set the type of input-output used by these sensors. So limit switches, you set up in the initialize.io, and encoders you set up in the void initialize. So here you need to run a command called pin mode. Okay, and this is where we're going to set the ports as inputs or outputs. So we're going to have a shoulder limit. Okay, and this is going to be set as an input because that's a sensor. It's not a putting out a signal to that. So input, okay, all caps. And close. Shoulder limit. I think that's just because I haven't saved my thing yet. And then we've got a pin mode. And, sorry, mode. And this one's going to be elbow limit. And we set this one as an input too. Okay, I think if we go here and go to main.h and make sure we save this. I think I need to take these away. Let me try that again. Okay, and then go back here to init.c. There they go away. So it's just because I hadn't saved it that it was showing a limit. So these are how you set up limit switch or any other digital sensor that is just a single port. You set it up here. Remember, shoulder limit is just another way of writing the port number. And then here, under encoder, we have to initialize the encoder in this section. So I think the command is encoder initialize. Okay, and then it wants to know the port numbers, the top port and the bottom port of the encoder, and then whether or not the encoder is reversed. So here I'm going to refer to this chart again. The encoders, the lower encoder, so the shoulder encoder is on port 6 and 7, and the upper encoder, the elbow encoder, is on port 8 and 9. So going back here to pros, we have encoder initialize, and we need to initialize an encoder on port 6 and 7, and is reversed, we're going to put false. I think it's all caps. No, it's lowercase, false. Okay. And then we're going to do the other one, which is on ports 8 and 9 and false. I'm not reversing my limit switches yet. Let me just double check. I think I need to put the name of the encoder in there 1 second. So I'm just checking the example folder here. No, this is probably not going to tell me. Okay. I'm going to quickly jump to Pros website. Pros. Okay, we're going to the Cortex documentation. I'm going to tutorials. Going to encoder tutorial. And encoder equals. Okay, so I need, this is the name of the encoder, then equals, then I run the function like this. So let's just add that here. So this would be shoulder encoder. And this would be elbow. Okay, so that's the 2 steps you need to do to set up your sensors. You need to declare their names in main.h, which we did right here. And you need to initialize them. The limit switches get initialized in initialize IO, and the encoders get initialized in void initialize. Okay, again, false is if you want to change the direction of positive counting for an encoder, you change this from false to true, and it'll reverse the direction of positive counting. All right. So we've done that step. Let's go back to our checklist. We've now, I think, completed all the things in this first part of the checklist, and we now want to set up the op control file with a button on the joystick for each function. And then we could test to make sure all the functions work. By this, we're just going to basically see that it shows a print command for each function. So like I said, this would be exactly the same. What we did right here would be the same for both types of projects. So I can just copy and paste this init .c into my other example project. So here we have, oops. So this is going to have exactly the same init.c. And of course, it's throwing a main.h error because I didn't put the code from main.h yet for initializing my sensors. So we just need these 4 lines to initialize the sensors. Remember, these lines have to go after the api.h command. So let's go down to init.c here, sorry, main.h. And we're going to add that code after api.h. Sorry, after include API. So then we can save this, and now we should be able to go back to our init.c, and all the errors are gone. Okay, so now both projects are at an equivalent state. I've caught that one up. So op control, this is where we're gonna go next, okay? So remember, the default op control program just prints hello pros user. So you might wanna change this to something, the /n makes it print on a new line. So we might wanna just change this to, instead of hello pros user, change it to I am working, so that it'll keep printing I am working every time the loop starts. Okay, so then of course all my code needs to go here inside op control between the beginning and the end. And this code, you should think about this code as being basically, like I said, all the functions on your robot live in their own place, and to execute any of those functions, you have to press a button. That's how we have it set up for driver control. In other words, nothing should happen unless a driver presses the button. If the driver presses the button or moves the joystick, then all the other features of your project should start working. So I already gave, in Clawbot example that I already shared, there's sort of the basic things that we need in op control. So let's copy and paste those, and then we'll add from there, okay? So inside op control, we need a void op control function. So copy this code. And again, this is shared in the Google Drive. So in operator control, the code that we want to place is this code here. And I, of course, have redundancy here at the beginning. So I'm going to remove this here because there's two functions. And I have an extra parentheses then at the end. And extra delay as well. Yeah, we'll remove the loop count stuff for now. And all right, so inside op control, we have print I'm working. It's just going to print I'm working each time this continuous loop repeats. Okay, and so then we need to get rid of this while loop because this is already running. Okay. Sorry, this is just because I copied and pasted something that was already there. Okay, so this while loop then needs to end the extra parentheses there. All right, so the first part of the op control, we already did this, is where you set the power to the number 2 channel and the turn to the number 1 channel, and then you run the chassis set function with power and turn. One is power plus turn, one is power minus turn, so that you can drive your robot using operator control. So just to double check here, we want to make sure that our chassis set function follows this. So we have an int right and an int left in our chassis control function. Currently, all chassis control is going to do is print this function is working, but we'd be able to see if that's working or not. So the next thing, so basically I've now used the chassis control function. That's the most important thing, that I've come up with a way to use the chassis control function. Okay. Now the reason why there's a bunch of errors here is I didn't include the chassis control chassis.h at the beginning of my project, like main.h. So the one thing you'll need to do if you use this method is to include all the other functions, all the other .h files that we created where our functions live. So we're going to have one chassis, and we're going to have one claw, and we're going to have one shoulder, and we're going to have one wrist, and we're going to have one elbow. And this basically gives your op control program access to all these other functions. And then in addition to those, we have home, shoulder. Actually, it's all lowercase. Here.h. We have home elbow. We have hold elbow. And we have hold shoulder. Okay, so now that we've included all those, they should not have these kinds of errors anymore. So we've included main, we've included all the rest of the functions in our thing. Okay, I think this is just a question of whether or not we've saved all these things. So let's go to include and save that. And op control, save that. I might need to do this file, save all. Okay, so then we're going to call the claw set, run it with the joystick. If the 6 up button is pressed, we're going to call shoulder set. If the 6 down button is pressed, we're going to call shoulder set. And else, we're going to change this. If we're not pressing those buttons in Clawbot 2.0, we want to hold the shoulder at a specific angle. And so we're going to change this from shoulder set to hold shoulder. In other words, is it going to hold the shoulder anytime we're not moving the shoulder? Similar, the elbow set moves the shoulder both forward and back, up and down. And then when we're not using the elbow, we're going to call elbow set to hold the elbow at a specific angle. Okay. Then in addition to those ones, we have we need to control the wrist. We've already controlled the claw, so we can repeat this and choose buttons to control the wrist. So probably it would make sense to use the buttons 7 up and 7 down to control the wrist. Again, this just looks a bit funny because it's not indented. And we're going to change all these from wrist, elbow to wrist, elbow to wrist, set. And there's no wrist hold function because there's no encoder on the wrist, so you can't hold it. So this is just wrist set again to a motor power of 0. Okay, W-R-I-S-T. I'm not sure why that's giving me an error. Wrist set. Oh, that's because we never created the wrist set function in here. So Control C. Let's do some catch up. So this is going to be wrist. Okay, and wrist set function called, and the name of this function is wrist set. And let's save this. Okay. So now I've called the functions for controlling the wrist, elbow, shoulder, claw, chassis. Okay, and the only functions I haven't yet called are functions to home the shoulder and home the elbow. So I think we can do those with just if statements because we don't have, we can't home, there's no 2 directions to home, there's only 1 direction to home, so we just need an if statement. So we have if here, and this if statement, if called, we want it to run, let's use the buttons 8, so let's use 8 up to home the shoulder. So shoulder, home shoulder. Home shoulder. And we're going to do this again. I don't like this incessant tabbing over that this thing does, but enter and enter. Erase the curly brace. Okay, and then for 8 down, we're going to run home elbow. How do you spell it? The home elbow function. Home shoulder should be working. Let's make sure. Did I misspell it? Home shoulder. Make sure it's saved. And I must have mistyped it. Okay, it'll probably disappear in a second. So now I've built out a way to call with the buttons and other controls on the joystick every single one of my functions. And there's going to be no difference here between the way this project op control file is set up because it's just calling a bunch of functions and those functions are saved within my project. So all of this would be the same in the other version of the project in Clawbot 2.0.1. So my op control would be all the same. So let's remove all this, except instead of including each of the different files, I'll just include #include my functions at the beginning. So include, and then quotation marks, functions, .h. Okay, because all my functions are living in functions.h, and then I will just paste my op control project here. Okay, so there's no difference here. If in this project, remember, we put all the functions in one place, and so we only need one include functions command here at the beginning, and all the functions will get included. Okay, so that's how you should set up your project for Clawbot 2.0. I'm going to save this classroom.